So one-to-one function. So review, what is a relation? What is a function? So types of relation. So these are the types of relations that we have. So we do have one-to-one, many-to-one, one-to-many, and then many-to-many. Okay? So one-to-one, many-to-one, these are functions. Okay? One-to-many, many-to-many are non-functions. A function is a rule that assigns a unique value to every member in its domain. So that's the illustration of a function. Yeah. Okay. Again, we say function is a rule that assigns a unique value to every member in its domain. So notation, f of 2, the function 2, that will be equal to 1 based on the illustration. Function 3, or f of 3, that will be equal to 7. F of 5 is 3, then f of 9 is 0. So the function consists of ordered pairs. So what are those ordered pairs? So we have 2 and 1, 3, 7, 5, 3, and then 9, 0. Okay. So g of 2 is 7, g of 3 is 7, g of 5 is 3, g of 9 is 0. So the ordered pairs, so we have 2, 7, 3, 7, 5, 3, 9, 0. Okay. But when we say one-to-one function, a function is one-to-one if, okay, take note of this one, if each value in each domain is assigned a different value in range. Okay? If each value in each domain is assigned a different value in the range. So that is one-to-one. Okay? In this particular second diagram or second illustration, is it one-to-one function? Anyone? In the second illustration, is it one-to-one function? Is it one-to-one function? Many-to-one. Many-to-one. So this one is not a one-to-one function. Why is it? Why is it? Why is it the second diagram or the second illustration is not a one-to-one function? Why is it? Okay. When we say one-to-one, they have different values. Okay? So in this particular example, it's not a one-to-one function because 2 and 3 has a same value which is 7. So it's not a one-to-one function. Okay? Obviously. So one-to-one functions have important properties that will make meaningful. So the formal definition of a one-to-one function, a function y is equal to f of x with domain as one-to-one if and only if for every x sub 1 and x sub 2 in the domain, okay, so the function of x sub 1 is equal to the function of x sub 2 implies that x sub 1 is equal to x sub 2. So in short, when we say one-to-one function, if each element of your function of the range is mapped from one and only one element in your x or in your domain. So what do you mean by that? What do you mean by that? What do you mean by that definition? A function is one-to-one if each element of the given function of the range is mapped from one and only one element in your domain. So what do you mean by that? What do you mean by that definition? What's your insight about that? What do you mean by that definition? Anyone? What do you mean by that definition? How do we know if it's a one-to-one function? Sige nga, how do we know if it's a one-to-one function? Hello? What do you mean by that? The range is mapped from one and only one element. So what do you mean by that? What do you mean by that? Okay, isa lang. Okay, isa lang. Okay. So for equation, we need to show that no two ordered pairs have the same y coordinate and different x coordinate. Okay. So we assume that there are two ordered pairs in the function with the same y coordinates. Then we show that x coordinate must be the same. So in summary, we show that the function x of 1 is equal to the function of x of 2 if and only if x of 1 is equal to x of 2. Okay. So for example, is f of x equals 3x minus 1 a one-to-one function? Okay, how do we know if f of x equals 3x minus 1 a one-to-one function? Okay, assume that outputs are equal. Okay, assume that their outputs are equal. Okay, so how do we do that? How do we verify that 3x minus 1 is a one-to-one function? Okay, so to evaluate 3x sub 1 minus 1 is equal to 3x sub 2 minus 1. Okay? So therefore, if you simplify it, x sub 1 is equal to x sub 2. So therefore, 3x minus 1 is a 1-to-1 function. Okay? It's a 1-to-1 function. Okay? Next example. X plus 2 over x plus 1. Is it a 1-to-1 function? So how do we verify it? How do we know that f of x equals x plus 2 over x plus 1 is a 1-to-1 function? So same thing. Okay? X sub 1 is equal to x sub 2. So you need to equate. X sub 1 plus 2 over x sub 1 plus 1 is equal to x sub 2 plus 2 over x sub 2 plus 1. Okay, simplify. So what will happen? X sub 1 is equal to x sub 2. So therefore, x plus 2 over x plus 1 is a 1-to-1 function. Okay? It's a 1-to-1 function. What about this one? F of x is equal to x squared plus 2. Is it a 1-to-1 function? Okay? Is it a 1-to-1 function? So same thing, you need to equate. X sub 1 squared plus 2x sub 1 is equal to x sub 2 squared plus 2x sub 2. Okay? So if you simplify that, it's not a 1-to-1 function. So obviously, because the given is a quadratic, it's a quadratic function. So more or less, there are two values of x. Okay? Two values of x, it's quadratic. So more or less, it's not a 1-to-1 function. But if you want to verify it, you need to come up with this solution to verify if that function is not a 1-to-1 function. But using the graph, it's not. Because obviously, it has two values of x. Okay, so it's not a 1-to-1 function. What about this one? F of x is equal to 3 multiplied by the square root of 4 minus x. Is it a 1-to-1 function? Okay, again, you equate it. So therefore, x sub 1 is equal to x sub 2. So therefore, it is a 1-to-1 function. Okay, it's a 1-to-1 function. So same thing with this one. F of x is equal to x minus 3 over x cubed. So to verify this one, you need to evaluate. So the other side must be sub 1 and the other side is sub 2. Okay? So in this particular, what have you noticed? It's not a 1-to-1 function. Since it's not necessary for x sub 1 to equal to x sub 2 to satisfy the equation, so it's not a 1-to-1 function. Okay? So what about the graph? How do we know if the graph is a 1-to-1 function? So we need to use the horizontal line test. A function y equals f of x is a 1-to-1 if and only if no horizontal line intersects the graph of y equals f of x in more than one point. Okay, in more than one point. So in this particular example, it's not a 1-to-1. Why is it? Why is it the first graph is not a 1-to-1 function? Using the horizontal line test. Why is it? Bakit? Bakit hindi siya 1-to-1 function? What have you noticed? In this graph, why is it it's not a 1-to-1 function? Hello? Can you hear me? Can you see me? Why is it in this graph it's not a 1-to-1 function? Hello? 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 Guys, can you hear me? Okay. So there are two intersecting points. It's not a 1-to-1 function. What about this? Y equals x cubed. Is it 1-to-1 or not? What about this? Is it 1-to-1 or not? Okay, 1-to-1. Why? Justify your answer. Why? Okay, next. What about this? Y equals x cubed plus 3x squared minus x minus 1. Is it 1-to-1 function? Is it 1-to-1 function? Is it 1-to-1 function? Based on your horizontal line test, is it 1-to-1 function? In letter B graph, is it a 1-to-1 function? Anybody? Okay, why is it? Why is it? What? Okay. Okay, very good. Okay. So it's not one. What about inverse function? Okay. So inverse function. So what is inverse function? Why would we want an inverse function? Suppose we had the following table of shoe size. So we have US shoe sizes and then European shoe sizes. For a given US shoe size, we would easily get the European shoe size. We can say that U is equal to U of E. Okay, U is equal to the U of E. So that's only an example. Okay. Similarly, we can easily get the US shoe size for a given European shoe size, or E is equal to E of U. Okay, we say that E is the inverse function of U. Okay, E is the inverse function of U. So there are many situations that we want the inverse function. Every function y equals fx has an inverse relation, and that will be x is equal to f of y. The inputs and outputs of ordered pairs of the function are interchanged to produce the ordered pairs of the inverse relation. So for example, given the function, okay, in ordered pairs, so 1, 1, 2, 3, 3, 1, 4, 2, its domain is 1, 2, 3, 4, and its range is 1, 2, 3. Okay? So the inverse relation of that, so your domain is 1, 2, 3, and then the range is 1, 2, 3, 4. Okay? So the domain of the inverse relation is the range of the original function. And then the range of the inverse relation is the domain of the original function. Okay? When different inputs produce same output, then the function is many to one. It's inverse, not a function. When the different inputs produce different outputs, then the function is 1 to 1. Its inverse is a function. So for a function y equals f of x, the inverse relation of the given function is a function if and only if the given function is 1 to 1. So for a function y equals to f of x, the inverse relation of the function is a function if and only if the graph of the given function passes the horizontal line test. Okay? Passes the horizontal line test. So if the function is 1 to 1, the inverse relation of the given function called the inverse function of the original function. Okay? The inverse function of f, or the inverse function of the original function. So the inverse function of y equals f of x is written as the inverse function of x. Okay? The inverse function of x. The inverse function of x is not an exponent, or it's not a reciprocal. Okay? So f is the inverse of x, or the inverse function of x. So for here, for example, x and y values of a point are switched. So the point 3 and 5 has the inverse point, which is 5 and 3. Okay? The point negative 2 and 0 has the inverse point of 0 and negative 2. So therefore, what is an inverse function? What is inverse function? Based on this graph, what is inverse function? How do we compare original function to inverse function? Based on your domain and range. What is inverse function? How do we determine the inverse function of your original function? Remember when we say inverse function, the domain of your original function, if you want to get the inverse, it should be what? Sa inverse. Yung domain daw ng original function, sa inverse function, yun yung range. Okay? And then yung range ng original function, that will be the domain of your inverse function. Okay? Do you get the point? Hello? Do you get the point? Hello? Okay, let's proceed now. So find the graph of the inverse relation from the graph of this function. F of x is equal to x cubed minus 2 over 4. So that is the graph of x cubed minus 2 over 4. Okay? So yung black graph, that is the original function. And then the green one, that is the inverse of that function. Okay? And then the graph of its relation and its inverse are the reflections about the line y equals x. Okay? Y equals x. So in here also, yan. So that's the graph of the given original function. So to find the inverse of a relation, algebraically interchange x and y and solve for y. So for example, find the inverse of the function f of x equals 3x plus 2. First, replace f of x with y. Okay, replace f of x with y. Second, switch x and y. So switch x and y. solve for y, and then replace y with the inverse function. Okay? Replace y with the inverse function. So another example. F of x is equal to 3x squared plus 2. Find its inverse. Find its inverse. In this particular example, if you have noticed, there are two values of y. Yung isa negative, yung isa positive. So therefore, there are two functions for the inverse? Because it's many to one function. The domain of the original function has to be restricted such that it becomes one-to-one function. So in this particular example, okay, it's not a one-to-one function. Kasi dalawa yung values ng y eh. Dalawa yung magiging values mo eh. Isang negative, isang positive. Okay? So determine the inverse of the function g and h. So same thing. Replace g of x by y. And then switch x and y. And then solve for y. And then write it with the inverse function of g of x. Okay? So same thing with h of x. So replace h of x with y. And then switch yung x and then y. And then you simplify. So it will become x plus 2 is equal to the cube root of y plus 1. And then get the cube of both sides. So it will become x plus 2 raised to 3 equals y plus 1. And then solve for y. Okay? So we have x plus 2 raised to 3 minus 1 equals y. And then replace y by your inverse function. Okay? So therefore, the inverse function of h of x is equal to x plus 2 raised to 3 minus 1. Okay? So understanding inverse function allows us to determine the domain and range of the function. So the domain of the inverse relation is the range of the original function. And then the range of the inverse relation is the domain of the original function. So try to take note of that one. So the domain of the inverse relation is the range of the original function. And then the range of the inverse relation is the domain of the original function. Okay. So determine the range of the given function, 3x over x minus 2. Okay. So this is easily doable by obtaining the domain of the inverse function, of the original function. So the inverse function of your original function will be 2x over x minus 3. So the range of the original function is the domain of your inverse function. Okay? So if the domain of the original function is negative to 2, union with 2 to positive infinity, therefore, the domain of your inverse function will be the range of your original function. Okay? And then the range of your inverse function is the domain of your original function. The inverse function is an inverse with respect to the operation of composition of function.